Let's just continue what we've been doing. When we see problems that look like this, we're going to distribute the 2. We'll distribute the 3. So let's distribute the 2. We're going to get 16s and 18. So we'll get 16s plus 18, and then minus 7s equals, and now let's distribute this 3. We'll get 9s plus 3. So we'll get 9s plus 3, and then we still have that minus 8. Now on the left side, we can tighten this up a little bit. 16 s's minus 7 of them leaves us 9. So we have 9 s's there, and then that minus 18, or plus 18. And on the left side, right side, you can probably see this already. There's the 9s, which matches that 9s, so we know there's going to be either no solution or no unique solution. Let's see what it is. What do we get here? 3 minus 8 is negative 5. All right, so I think you can see this now. Here's a number, you add 18. Here's the same number, you subtract 5. Those are going to give you different results. So there's no solution to this one. Now, just in case you don't see it, let's get the s's all on one side. So pick a side. It doesn't matter. Subtract them here or subtract them here. So if you decide to subtract 9s, what's going to happen is when you subtract it from the left side, 9s minus 9s, that's gone, and just get 0. Well, I don't even need to write this 0. I'm not going to do that. 9s minus 9s is gone. You get 18 equals, and then you subtract the 9s here. 9s minus 9s, again, is 0. It's gone. Negative 5. Now you've eliminated all the variables here, and you got a false statement. So now you have to realize that there is no solution. Okay, now you look at this number 18, and what you see is 5x equals 5x. Well, this is some number, and this is the same number. So no matter what you put in for x, you're going to get some number here, and then you get the same number over here. So this thing works for any value of x at all. So right now, if you can see it, you can just write no solution. Now, if you don't see that or don't want to see it that way, what you could do is get all the x's on one side. So what you could do is, okay, here's what I'm doing. I'm going to subtract 5x. That's what I'm thinking. I'll subtract that 5x. And when I do that, then I get, okay, on the left side, I get 5x minus 5x. No more x's. That's a 0 equals. And then on the right side, I get 5x minus 5x. That's no more x's, and that gives me a 0. And now I can see I've eliminated all the variables, and I have a true statement. So now I can conclude no solution. We've got some words to deal with here. Now, here's what we're told. Mary, she is n years old. Now, n could be some number. You know, we don't know what number it is. We don't know how old Mary is, so we'll just say n for a number of years, maybe. So just imagine, here's Mary. How old is she? N. She's n years old. So now what we want to do is write an expression for her age 12 years from now. Okay, well, if she's n years old now, how old is she going to be in 12 years? Well, what if she was 10? What would you do? If Mary was 10 years old now, how would she be in 12? What are you going to do? You're going to take the 10 and add 12. What if she was 20? In 12 years, she would be 20 plus 12. If she was 30, you take the 30 plus 12. But we don't know what n is, so what we're going to write here is just her age now, n plus 12. We've kind of seen this thing before, right? Here's that word from. So do you remember talking about this in the last section? When you see the word from, whatever comes after from, that's your starting point. So we had more than something, less than something, and from something. And whatever follows those words, that's where you start. So we start at now. So how old is Mary now? Well, right now, Mary is in. So we start there, and then she's 12 more. Now, what about 4 years ago? Well, 4 years ago, how old was she? What if she was 10? If Mary was 10 now, how old would she be 4 years ago? What are you doing? How are you getting it? You're taking 10 minus 4. If she was 20, you would take 20 minus the 4. But we don't know how old she is. She's n, so we're going to say, well, whatever age she is, n, we'll subtract 4. So there's the answer to the first question, the answer to the second one. We'll finish this section off with number 20. Now here's what we're told. A plane ticket costs C dollars for an adult and K dollars for a child. So we don't know what C is. It's just some kind of a cost, right? It's just some number. $100, $200, $10,000. We don't know what it is. Just some cost. K is the cost for a child's ticket. Now where the letters C and K came from, who knows? The writers just made those up. Could be any letters at all. So anyway, an adult ticket is C dollars. A child ticket is K dollars. Now, here's what we want to do. Write an expression, write some expression that represents the total cost for 8 adults and 6 children. Now, here's how we'll do this. What if there was just one adult? Just think about this. If there was just one adult, how much would a ticket be? Well, just one adult, a ticket is C dollars. So one adult, it would be just one of those C's. And then you add on to get the total, one child. What if you just had one child? Well, it would be the cost of an adult ticket plus the cost of a child ticket. Okay, now, what if you had 2 adults flying? So if there was 2 adults, you would have, what, 2 adult tickets. So you'd have C dollars for the first adult, C dollars for the second. So you'd have 2 of those C's, right? C plus C. So you'd have 2C. What if there was 3 adults? You would have C plus 3, or C, 3C. If you had 4 adults, it would be 4 of those C's. C plus C plus C plus C. Or 4C. But we've got 8 adults. So how much are those tickets going to be? Those tickets are going to be $8C dollars for those 8 adults, right? Does that make sense? C is the cost for one adult ticket, and you have 8 of them. So you have 8 of those adult tickets. Now, times, in algebra, you'll see that multiplication means of. So you have 8 of those adult tickets. But you want the total. So we're going to add to that the total of those child tickets. And there's 6 children. So we're going to have, let's write it here, we're going to have 6 of times those child tickets. So what we've written here is an expression that represents the total cost of 8 adults and 6 children.